So welcome back to another video. In today's video, I'm going to be taking a look at recursion. First, I'll go through an example from the lecture slides, and then I'll go through an example from the lab exercises. So recursion, in its most simple form, is really just a technique for solving problems using a function which calls itself. The easiest way to show it is probably going to be with an example. So this is an example from the lecture slides. It's the factorial calculation. Generally what that is let's say we had 5 factorial. That's just going to go from 1 to 5 using the multiplication operator, and you're going to end up with 120. It is commutative, meaning that order doesn't matter, so you can do it backwards, you can do it in any order at all, and you're still going to come up with the same value. When it comes to looking at the general form, this is what we're going to look at to find the recursive nature of the function. So the general form is when you say you're looking at n factorial, and you'll end up with something like this, 1 times 2 up until n equals n factorial. The other way you can look at it is working backwards, so you might have n times n minus 1 times whatever going down until 1 until n factorial. Now this is the hint, because this is what we're going to use to find our recursive function, and that's what shows the recursive nature. The recursive function is basically just n times n minus 1 factorial. So that's it there, and you can see it really clearly in this example. You can see that 5 factorial is really just 5 times 4 factorial, because down here you can see that from here down we've still got 4 factorial. If we had 4, it would be 4 times 3 factorial, and you can see that from here down you're just working with 3 factorial. So that's the recursive nature of this function and how we're looking at it to break it down, and that's what we're going to use to actually write the function itself when we get to writing it. There is a couple of key properties. The first one is that 0 factorial equals 1. That's just an arbitrary definition that's been defined for factorial, which is there just to make everything work. Extrapolating from that, we can then define that 1 factorial also equals 1, and that's a pretty simple conclusion to come to. All you'd have to see is that 1 factorial is really 1 times 0 factorial, which is essentially 1 times 1. So those two properties there are also something which we're going to use within our example code. So when it comes to writing the function, recursive functions are actually usually quite simple to write once you've written them. It's really just a matter of finding the right pattern. If we just take a look at this one, you can see I've got a function, I've defined it as factorial, it's going to return an integer, and it's going to take in a value for n. The first thing I want to do is look at the base case or the terminating case, and that's going to be the case that actually returns a defined value, and we're going to use that property that we talked about before. The property is going to be the 0 factorial equals 1. You can also see I'm using the property that 1 factorial equals 1. So in either of those cases, when n equals 1 or n equals 0, the program is going to return 1. If you ever end up in an infinite recursive loop, always check your base case. Make sure that your input is going to evaluate to that base case at some time, and make sure that that base case does actually stop the recursive nature of the function. The next part I'm going to write is going to be the actual recursive nature of the function, and that's my else condition, which is where I'm going to return n times another call to factorial using n minus 1. So what we want to do is trace the execution of this function. Let's say we were to call it with something like factorial 4, and the value we passed in to here was actually 4. What would happen is it would go into the else condition, it would go to return n times factorial n minus 1. So essentially we're going to make a call for factorial 3 at this point. Then we're going to go into the else condition and we're going to make a call to factorial 2, and then we're going to go into the else condition and make a call using factorial 1. At this point we've met our base case, and this is where n equals 1, so we're actually going to return the value 1. Now that we know what the value for factorial 1 is, we can step out into the call we made when n was 2, and we can evaluate what this here is, the n times factorial 1. We know that it's going to be 2 times 1. Then we're going to step out into factorial 3, and at this point we're going to know what the answer is because we can evaluate what 3 times factorial 2 is. So we're going to know that the answer is 6. And then again we can step out into factorial 4 because we know what the answer for factorial 3 is. So that's generally how a recursive function or a call stack works. You simply step through making your calls, and then you meet a base case, and then you move out again making all of your return cases and evaluating what they are. Okay, so now to see one actually up and running, I've made a little solution in Visual Studio. So this is an IDE so that we can use the debugger. Essentially I've got the factorial function here. Down here I've just got a simple main. I take in the value of n, and then I define what n factorial is. I make a call to factorial using that n value. So if I was to put a breakpoint in, and to put a breakpoint I just click here on the line where I want the program to stop executing so I can debug it, and I start debugging. So I'll give it a value to work with, and I'll give it 4, and then you can see here we're in the debug mode. My value of n is 4, and I'm on this call to factorial, and this is the call for where I am, and I'm using an unsigned integer. So if I just use the step over feature, I can go into it. I can see that n doesn't equal this, so I'll go into my else case. So I make the call, and you can see my n value has just changed to 3, and my call stack has increased by 1. So now I keep going through, and now I'm in my final case where n equals 1, and these are my call stack here. So what I'm going to do is I'll go into here, and now I'll start returning. So I'm going to return the value 1, and you can see when I return, I'm going to pop out of that, and you can see that the last call, I've popped it off my call stack, and I've now got a returned value of 1, and I'm working with the value 2. So this is where if I step out of it, you can see that my factorial returned is 2, and now I'm working with n equals 3. So this is exactly the same as what we were looking at before, just using the actual debugger to see it working. And now we're in our final case, and you can see I'm on my final factorial call here, and my returned value is 6 and my n value is 4. So if I step over that, I now go back into my program, I can punch out this line, and you can see there it is. That is what I've returned from factorial. Okay, so recursion, it looks simple enough when you're shown an example and you know what you're doing and you're working through it. It can be a little tricky after a while though to see the patterns. So I'm going to work through one more from this week's lab exercises. I'm going to take a look at the Fibonacci recursive sequence for you, and then I'm going to leave exercise 2 for you guys. So for this exercise, what I'm going to be doing is writing a recursive program that's going to return the nth element of the Fibonacci sequence. The Fibonacci sequence is really quite simple. It's just this sequence here. It's where any element is made up by adding the 2 preceding elements. So like 5 plus 8 is 13. To look at it in a recursive way, what I want to do first is establish my base cases. So my base case, my first one, is going to be when n equals 1, when I'm working with my first element, and that's going to return the value 1. The next base case is going to be when n equals 2 and I'm working with the second element, and that is also going to return the value 1. From there I can just use the recursive function or the recursive general form to define any other element. So you can see that this one here is simply n minus 2 plus n minus 1 is going to give me this value for the third element here, which is going to be 2. That would just keep going through all the way up until you get to the nth case and you get the Fibonacci value of n. So writing the function itself is really simple. In this case, we're just defining the function. It's going to take in an input of n and then it's going to be returning the value. The first thing we do is write out our base case, and that's when n equals 1 or n equals 2, and in either of these cases we're going to be returning the value of 1. Otherwise, what's going to happen is we're going to return the sum of Fibonacci n minus 1 and Fibonacci n minus 2. So you can see we've actually got two recursive calls happening here. This is going to have an effect on it when we're tracing the execution. So when you're running through it with your debugger, it can get confusing. And the reason why is because let's say we had Fib04. The first thing we need to realize is that this is going to make two calls. It's going to make a call to Fibonacci 3 and it's going to make a call to Fibonacci 2. Now it's going to do Fibonacci 3 first, and it's going to start going down this branch of the tree, and this is where we're going to make two calls in here. This is going to go to Fib02 and Fib01. Fortunately, both of these are base cases, so we'll evaluate this one first, which is where we'll define, okay, well this one is returning 1, and then it would evaluate the second case and it would see that it's returning 1 there as well. When it's finished evaluating these, it'll be able to step back out into this Fib03 case, and here we're going to be able to see that it's returning 2. Now it's going to be able to move on to evaluate Fib02, and at this point we're going to see we've hit a base case and we can return the value 1. And then finally, now we've got values for these two, we're going to be able to return the value 3 for Fib04. So taking a quick look at how that execution would grow at each level, let's say we wanted to do Fibonacci 5. Again, we'd be starting with two calls, one for Fib04 and one for Fib03. We'd be going through Fib04 first, but each of these essentially is going to also have two calls. In these cases, they're going to be the base cases, so they'll fill in quite easily, but in Fib03 we've still got another two calls to make. Which happen to be base cases, and then we'd be able to fill in our returns. Now the debugger, following this, it would start with a call from Fib05 to Fib04 to Fib03 to Fib02, then we'd return 1, then we'd make a call to Fib01, then we'd return another 1, then we'd step out, we'd return 2, we'd be making a call to Fib02 here, we'd be returning 1, then we'd be stepping out and returning 3, and then we'd be going down this branch of the tree like so. So it can be really hard following a recursive function like this with the debugger, simply because you do need to really be very well aware of where you're up to in the execution and what you're expecting to see happen. So that's the end of today's video on recursion. If you have any questions about your next exercise, ask your lab demonstrator about it, and yeah, good luck with it.